Hello everybody. Welcome back to another session on logic development. We are discussing in the last session dual alternative if. And we had taken some examples. We had discussed certain scenarios. I had given one assignment that was to help Monica make a decision. How many of you solved this particular assignment? Raise your hand, those who have solved it. So please share the file.
Sir, I have that in that logarithm file, not in PDF.
Yeah, please share the logarithm file. Ashish has also solved it. Who has also solved it. For those studied that question, I have just now shared in the chat window the problem statement. Let's have a look at the way Ashish has solved that particular problem. But even before I go ahead, let us have a look at the problem statement once again, and then go about discussing it. Yeah, the problem said, Monica needs to buy a present for her best friend, but she had two options. She can buy it online, or she can travel 30 kilometers to buy 30 kilometers to buy it at the store. So online is one, and going to the store is another option that she has. But she is not very sure which would be less expensive, considering the shipping and the handling cost to buy online. So if you're buying online, there is a transportation cost, there is a handling cost. But if you're going to go to the store, so there is a fuel cost which is involved. So the cost of the present is same. You buy online, you buy it by visiting the store. So we need to help Monica decide the best way to buy the present. So that was the problem statement. Let's see how Ashish has solved this particular example. So here he goes ahead, handling cost. Now Ashish, when you use variables, everything in small case becomes actually difficult. Here what you could have done, you should have done is, you should have used lower camel case. That means handling and then cost. So we take variables like handling cost, and that's a real variable. Then there is another variable called as shipping cost. So here also we would use lower camel case. Lower camel case.
We are not able to see your
You cannot see the screen. Is that visible now?
It's visible. Now it's visible.
So we had created some variables like handling cost, like look at the fuel cost. Now, if the variable name like handling cost is straightforward, it becomes difficult. So in that case, we said use lower camel case. Every next word's first letter we read capital. So fuel cost and real someone and integer sum two. Now, believe me, tell me what does it help you understand someone and sum two? Is it meaningful at all? Is it a problem regarding addition or subtraction? So this is just not the right name that we can come up with. Okay, someone sum two, and that to one real number, someone another one is integer sum two. Now it will only keep on wondering as to what this is all about. I expect all of you to turn on your cameras. It shouldn't be the case that you just are behind the screen. Okay, so these two variable names, someone and sub two, are not acceptable. Enter the shipping cost of the present in rupees. So there was a present that she had to buy for a friend. So he's asking for shipping cost. The shipping cost has been accepted. Then handling cost has been accepted. Then enter the current fuel cost per liter in rupees. Okay, fuel cost has been accepted. So shipping cost for handling cost is someone, or that could be online purchase cost. That's the name that we could have given to this particular variable. And fuel cost into 30. Now that's just not right. Okay, now this will not work out. And if someone is greater than sum two, now if somebody looks at this particular code in between, someone greater than sum two, then I'll do this. So you keep on wondering what is someone and sum two. So this was not the right way to go about. and plus this logic was also wrong. Sum 2 is equal to fuel cost into 30. Now that just doesn't make sense. Enter the current fuel cost per liter in rupees. So is it actually like 30 liters fuel is being used? So that's the cost that you are talking about. 30 liters fuel, that doesn't make sense. So there was a logical mistake as well. Let's see what Kaustubh has done, because he has also submitted the solution. So let's have a look at Kaustubh's solution. Variable name perfect, and the shipping cost, handling cost, fuel cost. That's okay. Please enter the shipping cost of the gift in rupees. Very good. Shipping cost has been accepted. Please enter the handling cost of the gift in rupees. That has been accepted. Please enter the fuel cost required for the trip in rupees. Now that could be okay. Either you could have accepted the fuel cost, but there is a question of 30 kilometers, correct? So you cannot ask the user to do the calculations on your behalf. You cannot ask the user to do calculation on your behalf. That means you are asking over here, enter the fuel cost required for the total trip. So user will have to do the actually what is the total fuel cost. So there again requires some kind of correction. The rest I think is almost right. But then I'll introduce some variables. This is near and better, but I'll introduce some variables. Shipping cost, handling cost. So I'll introduce one more variable over here. Okay, and that variable would be of type real, and I'll call this particular variable as online purchase cost.
Sir.
Yes.
Sir, so we have to calculate the fuel cost also.
Yes.
Okay, but so we have.
What
to
have you
calculate
done? You have passed on that responsibility to user.
Okay.
And when you develop an application, you should not pass any responsibility to the user. So there is an online purchase cost, and second could be offline purchase cost.
सर उसने इक्वल टू का भी एक केस लिए
सकता है ना, वो तो आपकी मर्जी क्या करना है.
इक्वल टू पे क्या होना चाहिए
आपकी मर्जी, आप कुछ भी सजेस्ट कर सकते हो, because that would not be wrong ना. Equal to पे दो में से कोई भी किया, then also it is okay. Yes or no? You could either give her a choice, like you can go with either mode, or you can still say go with online mode, because you are sure that this particular thing is going to work. Calculate the fuel cost. So that's total purchase cost. So rather than asking for fuel cost, I'll say fuel cost liter. Total trip distance is what I want. Distance is constant, so I'm going to assign it some value. $60 because she can travel 30 kilometers to buy that particular store. So we are not very sure over here whether it's one way or what. Okay, she can buy it online, or she can travel 30 kilometers to buy at the store. So we are not sure whether its total trip distance is 30 or 60. It doesn't clearly say whether it's one line, one side or both the sides. Let's assume it's both the sides. So total trip distance 30 kilometers. So we have asked her to calculate, we have asked for the fuel cost per liter. In addition to that, we will also require the
Average.
I say car mileage per liter. A lot of things. Now here, handling cost has been accepted, shipping cost has been accepted. So I am now going to put operation, and that's
Sir.
yes, please.
So we have assumed here she will be traveling to car. So you said that we have to act upon what has been given to us.
Let's see what
There
does the
is
statement
slightly
say. Does it say car or what it says? Travel will eliminate the word car.
But sir,
Shipping.
one way or two way, we can't assume that, no?
Since it has not
Kilometer.
been given, you cannot make an assumption. No? We will assume that the total she can buy online or she can travel 30 kilometers to buy at the store. Okay, so Kaustubh is right. It need not be by it does. Oh, here it talks about Kaustubh. Can you
Yes,
see that,
sir.
Kaustubh?
Yes, sir.
Okay, so involved with the fuel. Shipping cost plus handling cost. And one question about what Viraj was asking, whether it's two-way or one way, it is not been given. So she can travel 30 kilometers to buy that at the store. So we assume total cost travel distance is 30 kilometers because it has not been said whether it's one line, one side or what. So we have online purchase cost plus shipping is equal to shipping cost plus handling cost. That's online purchase cost. Enter the fuel cost required for the total trip. Instead of that, I'll now be asking, please enter what is the cost of fuel per liter. And that is expecting to enter the answer on rupees and what variable had we created. Yeah. Fuel cost per liter. Now, since it was about the fuel, that means obviously she's going to travel by her own vehicle. It could be a car, it could be a vehicle. So I could just use the word vehicle instead of saying car. It could have been truck also, who knows? It's per liter over research. That's it. So whatever we don't really care. Second. I say, what's how many meters does your vehicle travel in 1 liter fuel? I'm asking the question to you. Kilometers does your vehicle travel in 1 liter fuel? Okay. Will I accept that as well? It's per liter. So you know that fuel cost per liter and mileage per liter, we'll have to calculate the total offline purchase cost. Purchase cost is equal to your mileage liter into trip distance, mileage per liter into what is the total cost of the cost of the fuel?
100.
400.
Total
Mileage per
trip,
liter. Huh?
total trip,
Louder?
right?
Yes. So total distance divided by mileage per liter that will give me the total fuel that is required into fuel cost per liter. Liter. The cost of the gift is same in either case. Now we'll check over here condition. Instead of writing this total thing, I'll rather say if of is cost if purchase cost is greater than offline purchase cost is less than online purchase cost is less than. So we are now giving you a suggestion. If online purchase cost is less than or equal to, even if it's equal to, suggestion, why travel then unnecessary? Please buy the gift by whichever. If online purchase cost is less than or equal to offline purchase cost, you could think it's recommended to buy the gift online. That's the message that we have given. If online purchase cost is greater than or equal to also, even if it's same, why travel? Na? It's recommended to buy the gift online. And if we said truth, I said false. Okay. Say it's better to buy the gift store. Say it's recommended to buy the gift online. And then you stop. So that's how you could have solved this particular example. Now have a look at the solution. If you know if there are any suggestions that you have. We'll also run this particular code and see. The variable name should be consistent.
Sir,
Yes, please.
sir, what if we write please buy offline? It will make it shorter.
You are only supposed to give them the suggestion. So you give the suggestion, whatever statements you feel is important, that message, as long as it conveys the choice, that's good enough. So please enter the shipping cost of the gift in rupees. So shipping cost was suppose 50 rupees. Yeah, 400 rupees. It was too far off. Please enter the handling cost. That was 100 rupees. The shipping cost was 400. Handling was 100. So that is 500. What's the cost of the fuel in rupees? The cost of the fuel. What's the cost of the fuel per liter? So it's suppose 89 rupees per liter. And how many kilometers does your vehicle travel in 1 liter of fuel? It travels suppose 10 kilometers. It travels 10 kilometers. So in that case, it's recommended to buy the gift by visiting the store. Why is it that? Let us check. So it travels, the cost of fuel per liter is 89. You have to travel only 30 kilometers. And your vehicle gives a mileage of 10 liters, 10 kilometers per liter. So 10 kilometers per liter. So very obviously 30 kilometers ke liye it will hardly take any fuel. Okay. 3 liters also if I take. Okay. So even then, so it's better to visit the store. But scenario could have been different as well. So let's take another scenario. Let's say shipping cost is only 20 rupees. Hand cost is only 10 rupees. And your fuel per liter is suppose 80 rupees. And average is supposed to 20 kilometers per liter. So here we require only 30 rupees. Now here it says it's recommended to buy the gift online. Okay, so both the cases are currently being made. The good part over here is while we are running this particular code, we could have seen the flow by slowing down the speed with which it actually gets executed. So that's an option that we have. Let's try that as well. Speed, I'll take slow. Watch it carefully. And here input output that we are going to do. Let's run the code. So you can see as to how does it proceed further. In addition to that, you could also see the variables. If you wanted to have the details about the variables, that is also possible. The complete debugging is also possible now. These are all the variables that we are using in our program. So those are also visible. So here for your reference, or I could keep it here for your reference. All the variables. So our program is there. Your variables are there. Everything is there. Let's run the code. So we plan to debug this particular code. So slowly it goes ahead. Shipping cost variable is created, is not initialized. Handling cost created, not initialized. Fuel cost not initialized. Mileage per liter, total trip distance initialized. Offline purchase cost uninitialized. And now it's waiting over here. It has prompted the message, please enter the shipping cost of the gift in rupees. The shipping cost is suppose 150 rupees. Okay, that's input shipping cost. So we have accepted the shipping cost. So look at this 150 has been accepted over here. Look at the variables that we have. So 150 has been accepted over here. The rest all variables are uninitialized except for total trip distance. That's the only variable which is constant that has been initialized. Then we proceed further. Please enter the handling cost of the gift in rupees. The handling cost of the gift in rupees is suppose 140 rupees. Enter. First, 140 has now been stored. Now it says, what's the cost of the fuel per liter? Suppose it is 90 rupees per liter. Okay, so it's the mileage that your vehicle gives. Your vehicle gives a mileage of 25 kilometers. Yeah, suppose it's a two-wheeler, it gives you a mileage of 50 kilometers per liter. So yeah, mileage maybe 50 kilometers aa gaya. Now it has calculated. So while it is calculated, it has realized the offline purchase cost is 54 and online purchase cost is 290. So since the offline purchase cost is only 54, it says it's recommended to buy the gift by visiting the store, because offline purchase cost is only 54 with a vehicle which gives a liter and the cost of fuel is 90. It says offline is better rather than rather than purchasing it online. So that's how we have solved this particular example. Have a look at this particular example, and if there are any query, any questions, anything that you are you want to ask, you can ask. Have a look at it and ask if you have any questions.
Sir,
Yes, please.
sir, what if both the costs are same?
That's what Ashish had also asked. So it was your choice to give them the suggestions, correct? So I feel when both the costs are same, I say online purchase cost is less than or equal to offline purchase cost. So online and offline, both of them are same. That's the reason I have taken equal to. So in that case, I recommend to go online. Why travel when you're going to spend the same thing? That's my
Yes.
choice.
Yes, okay.
You have the discretion.
सर टोटल ट्रिप डिस्टेंस तो पहले से कांस्टेंट है ना 30
डिफाइन किया हाँ
तो फिर उसको एज अ वेरिएबल लेना जरूरी है या फिर
Of
इनटू
course.
30 कर
नहीं लोगे तो प्रोग्राम में कहीं तो 30 आएगा या आप कैलकुलेशन में कहीं तो 30 लिखोगे व्हाट इज द 30
Yes.
somebody looks at the calculation they will not understand. So to make your expressions more meaningful, any constant which has a meaning, the 30 had a meaning and the meaning was it was a distance. So always give names to them and use name variables in the program rather than using anything else. Here again the name of the variable was not right. I should have used D also as capital, since we have decided over here to use upper camel case for constants. Actually, ideally it should have been uppercase, all uppercase. I have decided to use upper camel case. I have done it over here correctly. How did it? Should I generate an error actually? But it did not consider the case. That's okay. Here, total trip distance, that's a constant. Then mileage per liter and divided by, so total trip distance is suppose 30 kilometers. 30 kilometers divided by your vehicle's mileage. So that gives you the total fuel that is required, and fuel required into cost of fuel per liter. So that will give the offline purchase cost. So once you get the offline and online purchase cost, we compare them and make a choice and tell it to the user, whatever your choice is.
Sir. Sir,
Bolo,
sir, what if you have a coupon code, for example,
pardon?
and you have a coupon code and it is reducing your cost of handling and shipping. So you will prefer going there. But
No, no,
if
these are hypothetical things. Is it been mentioned in the question?
no, sir, if there is a problem like that, then will you have to mention those two things also, like coupon value and all that?
Of course. If that was the scenario, so we'll have to take them into consideration. That was the case. Quick feedback, everybody. Have you understood the solution? Sharing this file with you all.
Sir,
Yes, please.
sir, how did you convert this file in PDF format using external tool or?
No, have a look over here. Have a look over here. So I just saved it. And if I had to convert it, I just say print. And once you print, it will print it to PDF. So I just say print. And it will print to PDF.
Okay,
Okay. Monica. It was just a PDF file. But I would recommend you to share with me the flowchart, this logarithm file only, because then I did not have to type everything again. I could make changes in your code as I did right now. And that's easy to test also why your algorithm is right or not. And it's easy for me to prove. So I'm sharing the file. Let me just know whether all of you have received the file. I shared two files. see both the files,
Yes,
the
sir.
PDF file as well as the other file. Sita, turn on your camera. Sagar, turn on your camera. Shreyash, hai. Okay. Sagar, yourself and turn on your camera. Sagar, have you understood? Yes or no?
Yes, sir. Sir, I have not understood the current app because I am a newcomer, no? So I attended the first lecture only from the YouTube, the link
Okay.
which was given to me.
But did you understand the discussion that we had right now?
Yes, sir. Yes.
Install Flogorithm for whatever reason on your machine and you want to use it. So if you visit their site, here we have an installer and here we have only an exe. This exe does not require installation. You can just double click on it and start. So you can download this exe if you don't want to install, and you can download this if you really want to install. So that's your choice. So either of the place you can go ahead download. You could just take this, and once you download it, you just don't have to install it. You can directly, it's exe file only. You can just double click on the exe file and execute. It does not require any installation. It's just an exe file. Like what I have on my machine, I have an exe file that I just double click and I can open up. I double click on this file and that Flogorithm starts. So there is no installation required, nothing. So you could take it from either place. So for those who are not there earlier, I'm just sharing this link for you to download it. Now that we have taken up this particular question, let's now go to the next level. And mark my word, notice even now you're missing out on that problem statements. You have to take utmost precaution. You have to take as much time as you need, but make sure that you do not misinterpret the statement. So take time, go through it very carefully, understand what the problem is demanding, and then go ahead solving it. Don't be in a hurry to solve the things. Okay. Now, when you talk about this algorithms, what we have taken is single alternative and dual alternative. Now, these are there. A lot of times you have to make some complex decisions. And while you are making those complex decisions, there are more than one conditions that we need to check. But while you go ahead writing your algorithm, there are some scenarios that we come across. There is something called as straight through logic. There is something called like positive logic. There is something called as negative logic. Let me give you one example of each. So when we make, there are scenarios where we have to make multiple decisions. It is not like एक decision से we reach the final answer. That doesn't happen. So for you to conclude something, for you to reach the final answer, you have to make multiple decisions. Now, if I have to make multiple decisions for me to reach the final answer, then those representation of solutions changes slightly. So let's have a look at it, how the representations can slightly vary when there are multiple decisions that we have to make. Okay. And take up one example of each, and then I'll give assignments based on those. The first one, when we are required to make multiple decisions, so it says there are 3 types of decision logic you can use to write algorithms for solution consisting of more than one decision. Currently, in all the examples, we had only a single decision that we had to make. But life is not that easy. A lot of solutions, we have to check for more than one conditions. So while you are checking for more than one conditions, there are 3 types of structures that we get. One is straight through logic, second is positive logic, and third is negative logic. So let me just quickly explain you what is this straight through logic. And we are going to take an example based on the same. And then I'll give you an assignment which you will have to solve like every time, discuss and then solve. So let's focus on this straight through logic. What does this straight through logic means? Any guess, anybody? No guesswork? Okay, let's proceed further. Straight through logic means that all the decisions are processed in sequence. Till now, we have been executing all instructions in sequence. Now there are going to be more than one condition, and no condition will be skipped. One after another, all the conditions will be executed in a sequence. Listen to me very carefully. One after another, all the conditions will be executed one after another. No condition will be skipped. So decisions are processed sequentially in straight through logic. Now keep in mind, when you come across such situations, when the conditions are unrelated, the decisions that you have to make or the conditional operation that we perform over there, the first condition has nothing to do with the second condition. If that is the case, that's the time when we come across this straight through logic. So there is no else part. Okay, there is only one condition and then go to the another condition. The false branch always goes to the next decision. That means if the condition is true, I'll do something. But if the condition is false, I'll do something else. There is some other condition that I'm going to check. The true branch goes to the next decision after the instruction for the true branch has been processed. So false है तो भी else आगे जाने वाले हो और true है तो भी the next decision पे जाने वाले हो. So the next condition will check irrespective your answer is true or false. So even if it's true or even if it's false, you're going to check for the next condition. When decision following straight through logic, all conditions are tested. So it will never happen that some condition is skipped. All conditions will be tested. Straight through logic is less efficient of all the types of decision logic because all decisions must be processed. But some problems demand it, so you don't have a choice. Here, if there are 5 conditions, you have to check for all the 5 conditions. However, you must use it to solve certain problems. Those that require 2 or more unrelated decisions and those in which all decisions must be processed. I'll rather go to the first part. When there are 2 or more decisions and they are unrelated. So whenever unrelated decisions are to be checked, we have no choice but to go through with straight through logic. It is often used in conjunction with 2 logic types and data validation. Check for data to make it sure is correct. This is bit advanced, we have not yet discussed, so we'll keep this aside. Last point, but let's take an example to understand. We say it is required when all decisions must be processed and when they are independent of each other. That means every decision is independent, has nothing to do with the previous decision. It is also used with languages that have limited features in the decision structures. Okay, now look at the scenario. Look at the problem statement. It says the problem is to change value of x to 0 when x becomes greater than 100. If x is greater than 100, it should become 0. And to change the value of y to 0 when y becomes greater than or equal to 250. Now, the condition to check for the value of x has nothing to do with the value of y because these are 2 independent things. The x value is greater than 100, then x becomes 0. Y value is greater than 250, then y becomes 0. Now, is the second condition depend on the first, or is the first condition depend on the second? These are 2 independent conditions. So when you come across such situations where there are independent decisions to be made, in that case, we'll think about straight through logic. Each decision is independent of other. So the first decision has no bearing on the second one. The conditions are straight through logic is required when all decisions must be processed and when they are independent of each other. So this much statement is good enough when to use it. When all decisions are to be processed and when all those conditions are independent of each other. Based on this criteria, the only appropriate logic type for decision would be straight through logic. How would you express it? I could say first condition, if x is greater than 0, if 100, that's true, then I set x value as 0. But either it is true or false, I'll still go and check for the second condition. If the second condition is true, I also set to y to 0 and then I'll proceed further. Look at this, if and if. If and if. There is no else part. So first condition ka outcome, whether the condition was true or false, you will still check for the second condition. So that's straight through logic. Have you understood this before I take a problem statement? Let's take a problem statement which will sharing the screen with you all. Just let me know if you have received the problem statement. Have you all received the problem statement?
Yes, sir.
Yes, sir.
Ah, hold on. Like always, we'll break out into rooms. I give you time to discuss it. Come up with a solution as early as possible. Say, how much time will you need to solve this particular question? Tell me. 15 minutes to solve this. I want you to 10 minutes is good enough. 10 minutes to solve these things. It's 9:05. So 9:15 we back and see which team has completed it. So I'll put you into various teams. So we'll have 4 teams.
Sir,
Yes, please.
sir, just wait for a minute. I have not downloaded it.
Shall I? Yes, please. So you all are now we'll go into various rooms. Please join your respective rooms and start with the discussion. It's 9:07. We meet again in 15 minutes, 10 minutes. Sagar and Kaustubh, join the rooms. Sagar, join the room. Sagar, you have difficulty? Sagar, join the room, please.
So currently I'm not on computers, that's why.
Hello, Sagar. I want all of you to share your solutions, all the teams. And what I saw was team one was very near to the solution, near. So team one also need to share the solution. Everybody needs to share the solution. We'll check out about it once again. Okay, other team. Yeah. Right or wrong doesn't matter.
Ruturaj, sure.
Yes, I need. Shy, share your screen. Share your solutions. Rahul, Bhagyashree, your team. Sairam, your team. Prithviraj, your team.
Sir, I
Yes,
sent
sir.
you.
Only team one has shared the solution. What about rest?
Sir, I sent you.
Let's have a look at this solution. I think this was very near, but not right. Let's see what are things have they done. First, they have taken a variable of type Boolean. That was a very good choice. Because Boolean, we will have only two possible inputs, either true or false. So that was a very good choice. Solar heater installed. It would have been better if it had said is solar heater installed. Okay, instead of saying solar heater installed. Owner is female. So is owner female would have been a better one. Property has four-wheeler parking. So is four-wheeler parking available? Okay. Rebate, then annual property tax. Okay. Rebate percentage. Okay, and that's 50%. Now you are seeing rebate percent, that's 50%. Let's look at the problem statement once again. Where is the rebate percent given as 50%?
If property is owned by a female,
Owned by female, then there is a rebate percentage. So the rebate percentage is only for female owner. Huh? Then you have taken one variable called as rebate, whose value is 500. Now, is that rebate for solar heater or is that rebate for parking? Team one, come on, tell me.
Sir, we have to,
Rebate, is it for solar heater or is it for parking?
sir, we have taken it common, sir.
You have taken it common. Very good. Tomorrow, if it so happens that solar heater rebate becomes 600, whereas parking remains 500. Now, what will happen? Will it work?
No, sir.
Yes, sir.
So just one variable over here as rebate was not good enough. You should I use solar heater rebate and what could have been parking rebate. So this
Yes.
variable would have been
Sir,
ah,
when we initialize a variable and provide it a value, then we have to use this case. So it is not constant, right?
no, not necessarily it is constant. In our case, we are going to use this as constant. Okay, and only the problem was in this logarithm, it was not allowing us to use all caps with an underscore. So we are using naming convention. But then if I initialize a variable, that does not mean you cannot change its value. You can change its value. Here by using variable naming convention, upper camel case, we are telling the user, we do not expect them to change the value of the variable. That's what we are trying to convey. We have one as solar heater rebate. Also have to have parking rebate. say four-wheeler parking rebate, what it is, but parking rebate is something that we'll have to have. So these are two different, and I tried to give you all a hint. I said, "Arey, kuch miss ho raha hai aapka." So parking rebate, and this parking rebate was also 500. So the temptation to use this as the same variable because the value is same. That was the temptation. But keep in mind, I said it is constant for that execution of the program, does not mean it's constant for lifetime of the application. So while I'm running the program, the value of this variable is not supposed to change. But next time when I run the program, that time the value probably may have been different. But while the program is running, that time the value is not going to change. So there is a difference. Then you have a variable called as total rebate, and you haven't declared it, or you have declared it. So you have declared this variable as total rebate, and I wonder why it has been initialized to value as 0. Enter the property tax per year in rupees. Okay. Enter property tax per year in rupees. Okay. What does the question say? Municipal corporation charges property tax to all its citizens per year. Okay. Ask a question. Enter the property tax per year in rupees. Okay.
Sir, what's your property, annual property tax?
The property tax. It could be for any property, correct? What's the property tax per year? And we are given the units, that is rupees. So input annual property tax, that's okay. Enter true if you have solar heater installed, else enter false. I could change this message to something slightly different. Look at this. What am I changing it as? I could change the message saying, I'm saying, do you have solar heater installed? And I'm giving a hint saying I'm expecting answer either as true or answer as false. Again, saying, do you have solar heater installed? True or false? So solar heater installed is a variable, we will accept the value. And then we're checking solar heater installed. This is correct. It will work correct. If it is there, then total rebate is equal to rebate. It was solar heater rebate. Now look at this. In this program, this variable total rebate has been initialized over here. So there is no need for you to initialize this value as 0, because you will be storing some value into that particular variable. Acha, you are using it over here directly. Rebate is equal to rebate plus this. Okay, so that makes sense. So there was a possibility that this particular variable may be used for the first time directly. You may be reading its initial value. So that was a good thought. And that was correct. Total rebate needs to initialize the value as 0.
Some languages also give garbage value.
Louder?
Some languages also give uninitialized variable as 0. Garbage value. Sorry.
Yeah. But then
So for
initializing this to 0, there is another reason for it. The reason for that was
yes.
I had given one rule. In the first place where we are using the variable in the program, okay, if that is of assignment, then you may not initialize. But if you are trying to read the value at the first place, then you have to initialize. Here, if the first condition is false, I'm going to use that variable. I'm reading its value. So in that case, that has to be initialized. With respect to your language, gives you 0 initialization or not, it is always better practice to initialize that variable. If the first time where I'm using that variable is that of reading, you are trying to read its value, then such variable needs to be initialized. Annual property tax, real rebate percentage, that's 50% you have taken. And we have decided to use some naming convention. percentage. But what are the rebate percentage for female owner? Let's say rebate percentage female owner. And we proceed further. Here, although this is going to work right, solar data installed. It's a Boolean variable. If it is true, it will go this side. If it's false, it will come here. But I still recommend you to write in this fashion.
Equals
Is solar data
to.
installed equal to true. That will just make it more readable. So solar installed equal to true. अगर true है तो यहाँ, false है तो यहाँ.
Sir, double
Solar
equals.
installed, pardon.
Double equals.
See what happens. Let's see. Okay, whether it says double equal or single equal, what happens? What does
Okay.
logarithm do? Let's check it out. Okay. Again, we are asking you that enter true if you are a female, otherwise enters false. So the operator may be a male, but the property may be of the female. So is the property owner female or male? That's what is important. I'll just ask a simple question. Is the I'm saying, is the property owner a female? True or false?
Sir, new line लागेल.
A variable पढ़ा है. Rate percentage. What is that?
0.5.
Percentage per female owner. Into annual profit tax, that's okay. Plus total rebate.
double quotes and
Property has four-wheeler parking. some other variable that we have defined. We'll have to use that variable.
Solar heater
Master?
rebate. Solar rebate. Solar heater rebate.
Solar heater rebate. Constant कहाँ गया?
सर नहीं किया
नहीं किया?
ठीक है.
नहीं है
Rebate.
पार्किंग रिबेट पार्किंग
Parking rebate.
Run this particular code and see. What is the property tax? Say I say property tax is suppose 5,000. Do you have Solar heater installed? I say false. Is the property owner a female? I say false. Do you have four-wheeler parking? False. In that case, total rebate is rupees 0. But have you been asked the total rebate or have you been asked the total tax? Calculate the total rebate and the particular citizen gets from the property payment, property tax payment. Calculate the total rebate that the particular citizen gets from his property tax payment. So we are supposed to calculate the here he has got no rebate. So Sairam, your question was, should we use double equal to or single equal to? So double single equal to is working. Okay, otherwise it would have given us a different answer in this case.
या the assignment साठी वेगळा आहेच आहे ना सेक्शन आहे. Maybe त्यामुळे.
That was the first thing that we got. Now let's take another scenario where he is supposed to get the rebates. Let's see the scenarios then. What happens? We'll try and trace the code. Also decide upon the speed.
Sir, is it case sensitive?
It should you should be careful about case, but a lot of places it is not case sensitive. Here also I don't think it is case sensitive, but you have to be better being careful with the case. So make it a practice. Even if your language is not case sensitive, you make sure that when you write the code, always maintain the case sensitive. Yeah. So yeah, one after another, all the variables have been created. Now property tax is again rupees 5,000. Then we have been asked, do you have a solar installed? I say yes. So we should get 500 rupees for that. Then yeah, we have calculated 500. And we are checking, is the owner of the property female? Let's change the spelling also, female. So I say true. Let's see where the control goes. It has correctly got the true part. Okay. Asking, does the property have a four-wheeler parking? I say true. See the flow, how it is checking. So we need to take all the inputs so that all the paths are being checked. So now this path is also being checked. If condition true hai, so that is been added. And total rebate is now 3,500. So let's check whether it is 3,500 is correct or not. Here, property owner female rebate is 50% of the property tax. So your solution is wrong. 50% of the property tax. So वही उसका 5,000 का 2,500 it should have become. Okay. Plus, you will get 500 and 500. Oh, that's correct. 3,500. The total rebate will be 2,500. That is 50%. And plus 500 rupees for solar and 500 rupees for the parking. So that is 2,500. That is correct. So now the solution has worked out right. So we have checked for all the cases. In दोनों case देखा है हमने. We followed both the course of action That means when the conditions were true and when the condition is false. And we have checked whether it is giving us the right answer. So this was the solution for that particular problem statement. Now, if you have any questions, please ask.
Sir, for female, it will be 1500, na?
2500.
So their profit is 5,000. 5,000 for 50% became 2,500. And plus
Yes, sir.
500 for solar and 500 for parking.
Okay, they added it.
Yes, of course. Congratulations, team one, to reach very near to the solution. Or it was almost right. Or it was correct only. I don't think we made any changes except the cosmetic one. Oh, we made one changes regarding the rebate. That was the only change that we made. Rest all things were right. I'm sharing the solution with the rest. And I expect all of you to make necessary changes in your program as well. So that has been shared. So one small assignment for this, have at this particular problem statement, and I am sharing the problem statement as well with you all. But also have a look at the problem statement. It's a simple problem that we have now as compared to what you have currently solved. But however simple the problem may be, you have to be very careful. Because we have seen simple problems also, things do not turn out to be the way we want it. So there is a problem statement that I shared with you all. Have a look at the problem statement as well. It says when the age is greater than or equal to 21, the person can have alcoholic beverages. I don't know why. When the age of the person is greater than 18, the person can vote. At age 20, a person can vote but cannot be served alcoholic beverages. Print enjoy your drink if the person can be served alcoholic beverages. Print you can vote if the person is able to vote. Correct? Pseudocode and flowchart both for this. I shared the problem statement with you all. I hope you have received the problem statement. See the problem statement, yes or no?
Yes.
Yes, sir.
That note, we'll stop here today. Tomorrow, we go to the next part of our discussion. We will discuss positive and negative logic, but I want all of you to solve this assignment and be ready. Even the other teams who could not get the previous one, make sure that you revise, check that thing out and solve that problem on your own. So on that note, stop here today. See you all. Take care. Love you all. Bye-bye.